All right, welcome back to Intro Technology 1023. We're going to be going over RAM today, or system memory as some would call it. Okay, system memory, randomly accessible memory. This is what RAM stands for, and generally speaking, is used to hold data that the CPU is going to need uh, relatively quickly that is not on any of the L caches. Okay, so this is generally speaking considered a highway. So as long as you have enough lanes to support the traffic, having more RAM doesn't help you at all. It's just more lanes for traffic that's not there. Okay. RAM standard DDR, the first one, so double data rate. Okay. Each DDR generation results in about doubling of performance. And this has been true for the entire history so far. We'll see what happens with DDR6 if they can actually achieve that. So we are releasing DDR5 as we speak. Intel's new platform has it, largely speaking because of the pandemic. A lot of systems are still using DDR4, but we will transition out of that relatively quickly as DDR5 becomes more popular and we have a little bit more supply in the market. But we will see what happens with that. Markets are struggling to keep up right now, and it kind of looks like we're going to go into a recession as well. So DDR5 might get hit pretty hard here, and with the rest of the new equipment as well. Okay, so the link below is the data rates website where you can refer to it. Okay, RAM specs, in particular clock speed. So before I start getting into this slide and what this actually means, what I do have to say here is that there's only a handful of things that you really need to consider at your level for RAM specifications. I'm going to go over all of them. If you ever get into the point where you are hyper specialized system integrator, system builder, that type of thing, where you need to know these specs, well, at least at a minimum, you've been exposed to it and you know that you can actually Google it. So back to clock speed, okay? Typically measured in megahertz. This will change if we ever get into the gigahertz range, just like we did with CPUs, where it started as megahertz and now we're at gigahertz. But as for the time being, we're at megahertz. States how many cycles per second a RAM kit has, just like in the CPU. Okay, major components to RAM throughput is clock speed and what's going to be cast latency timings. Okay, and we'll get into that in just a second. Max speed is dependent on the CPU, cast timings, and motherboard quality as well. Those are secondary factors. If you have a particularly slow CPU, it is possible to limit the throughput on your RAM kit. Uh, Rule of thumb, typically, okay, multiply the frequency by 8 to get the max throughput. Obviously, this is not going to be hyper precise, but for your level, pretty good rule of thumb. All right, timings, measure of latencies. Okay, so what this does, and there's a bunch of different latencies, how long it takes to do a particular thing, but what this does, latency, is hey, if I need to do a task, how long is that going to take? And based on that number, that's going to have a significant performance implications on that RAM kit. So you can have an extremely high clocked RAM kit, but if the latencies are equally as high, it's not going to be any faster. Okay, CAS. Column access stroke gas latency is the time it takes for the memory module to start responding to a data request. So this is by far and away the most important latency number in your RAM kit. This is basically, with the incorporation of clock speed as well, how long it takes for data to come back from the RAM. So as soon as it gets it, as soon as it gets the request, how long is it going to take to get data back? So the formula for this is cast divided by clock speed times 2000, and this is going to give you a value in nanoseconds, okay, for how long it takes to get information off the RAM. Now, to be clear, uh, This is a long time for the CPU. So if it always has to go back to the RAM to get something, that system's going to perform very, very poorly. If you need something that is going to be called over and over and over and over again, that needs to be on the L cache. Typically, at a programmer's level, for what we're targeting and what we're training for, um, you're going to let the CPU and the operating system, not the CPU, but the programming language and the operating system handle that for you. If you ever get into the lower level programming languages where you're doing truly custom work and it does one thing and one thing really well, and you want that to be as fast as possible, then you'll get into the manual memory management uh, type world where you'll have to understand this a little bit more and manipulate it a little bit more. But at the level that we're targeting here at Alfred State, that is not true. We will not be doing that very much. We'll expose you to it a little bit, but we're primarily focused on skill set. What can you walk out with that is useful for the market? And the market right now is just trying to build software and features as fast as possible. Not really worried about memory management at the moment. Okay. These RCD, okay, row access column address delay. TRCD latency is the time it takes for the memory module to respond with the row and then column which the data is located. Okay, so how long does it take to find the data? That's what that comes down to. All right. TRP stands for row pre-charge time, how long it takes to open a new row. Okay, so if you're adding new data to the RAM, how long does that take? TRAS, row active time, the minimum clock cycles that the data must stay open for data integrity. Okay, pretty self-explanatory. And to be clear, there we have videos again, and just like in the other lectures, I don't want to copyright strike, and I don't want to waste the time of the people that I took this from, simply because this is going to show up on copyright for YouTube, so I don't want to waste their time either. Okay, so this is how you're going to see RAM specs in your websites that you're trying to purchase from on the box if you're actually doing it physically. The only thing I'm not showing here is the clock speed. Clock speed is going to be on the front of everything because that's how people market it. But your latency is extremely important as well. So the first number is CAS latency, by far and away the most important one. Okay, TRCD, second, TRP, the third. Typically, these two are the same. And then TRAS, in terms of how many cycles this is going to stay open for, is the last one. Now, this last one doesn't matter. It really doesn't for what you're trying to do and what you're trying to spec out. If you get into the world where you have to hyper optimize like that, you're probably already an expert anyways, and you know what you're doing. Okay, RAM specs and capacity. Okay, the easiest concept to understand for most students. How much data can you store on the RAM stick? Okay, typically speaking, the bigger the capacity, slower the speed. So both in latency and clock. Voltage, how much power that's going to take. Now, typically this is based on a standard that is set by JEDEC, but manufacturers, if they're overclocking their kits, this is going to be a little different. ECC. Okay, so this is a important concept, especially if you're going to be in the server world. So ECC stands for error correcting code. And what this does is it corrects for memory errors like bit flips. Now, bit flips are caused by two things. And I'm going to start with thermals because that makes sense to people as the environment for the RAM heats up. The chances that a electrical problem is going to happen between those bits is higher. Okay. The other problem is cosmic rays. Now, people don't necessarily know what that means right offhand when we say that, but typically we're talking about light. So the more light that this is exposed to, the worse it's going to be. However, it doesn't happen that often, once per gigabyte per year on average. Okay. So for consumer, that's 16 bit flips per year Not a big deal. And then on top of that, if that bit flip is in a portion of RAM that is actually not critical, you're not even going to see that problem. And then once it's overwritten, it's gone. It doesn't really matter. So Cosmic Grays, in terms of bit flips, doesn't really become a problem until your data center, like a Google, where you have terabytes and terabytes of RAM, where this is going to happen on a daily basis. And then if the system crashes because of a bit flip, that's a problem. And then you add on thermals as well, then ECC becomes much more of a requirement when you're in that type of environment. Now, if you end up in a scenario where your business leader or your customer goes, I want the most reliable system possible, you're going to have to go with ECC. It's just that simple. Regardless if they need it or not, there's something about uptime and reliability that people are very, how do I put this? Risk averse with. They don't necessarily want to deal with equipment that is not working, even if it is as simple as just restarting the server. Okay, JEDEC is the ECC standard. It is the RAM standard in general, but JEDEC controls the standard here. And then the link down below is the JEDEC website for ECC. Okay, registered RAM. Registered RAM is DRAM that is registered between modules. What that means is that the DRAM talks to itself. So this, actually, let's back up a little bit. So one of the things I didn't talk about on the CPU section was that the memory controller is typically located on the CPU as well. So when you have consumer RAM that is not registered, the CPU memory controller has to communicate between the RAM sticks. With registered RAM, that's not the case. And because they're so much closer to each other, it's a little bit better as well. And then there's driver differences to make it a little bit more stable. So registered RAM, again, is a server feature. If you need a high uptime, never crashes type system, registered RAM is important. There's a difference between registered RAM and ECC. However, if you're in that environment, more than likely, you're going to have both features. Okay. Unregistered RAM, this is your typical consumer RAM. Okay, exactly what you think it is. You're going to have clock speed, going to have your latencies, and you're not going to have any other features. Your CPU is going to handle the communication. Your motherboard is going to determine the quality of the electrical path to the CPU and the RAM. So, and this naturally makes it cheaper as well. Less features, less engineering, less valid less validation that has to go into the RAM. Yeah, it makes it cheaper. So this is typically what you see on consumer platforms. And even for me, for my own servers, or even something as big as Alfred State, where we have, let's say, 200 students at any given time, we really don't need registered ECC RAM at all. Not really. And none of those services are mission critical that we can't just restart the server. Just not that important. Something along the lines of engineering simulations or mission critical services. So like military applications jump to mind. Yes, at that point you need registered and ECC RAM. Okay, ranks. So this is something that most people don't consider when they buy their RAM. You have your single-sided, double-sided. So the only difference here is that how many, if I hold up a RAM stick, how many sides have actual memory modules on it, single-sided or double-sided. That's not too much of a big deal. What is more of a big deal is dual rank and quad rank RAM sticks. And what this does is the more ranks that you have, the better latency you're going to have. And the reason for this is because the memory module itself, so if I pull up my little cursor here, the more of these that I have, the less latency there is, because it's quite literally how this data is stored is in a table. So the smaller this table is, the quicker I can find that information. So as long as I know what memory module is holding this data, the table itself is smaller, so I'm going to get back that data faster. Okay, so that's your primary difference. The more ranks that you have, the latency is going to be a little bit better and a little bit more stable as well. So in terms of IOPS, it's going to be a little bit better. Okay, so you have two main types. You have your SODIMM, which is for your laptops, and then, SDRAM, typically people are going to call it DRAM, is your typical standard full-size desktop RAM. All right. Okay, use cases. If you want fast RAM, or the use cases for the argument for having fast RAM and not stable RAM. Gaming, cache server, streaming server. Okay, all those things are incorporating and ingesting or sending out lots amounts of data at any given time. Gaming in particular is going to have a lot of IOPS to it, not necessarily throughput. So a cache server can ingest a bunch of data at once, especially if you have a high performance network. Faster RAM is actually pretty important there. And then if that caching server is just getting rid of that data almost immediately, ECC doesn't make as much sense. Now, if you have a caching server where it's perpetual data, where it's going to stay on there for a while, ECC becomes more important. Okay. Uh, Note that the fast RAM nets little performance increase in modern hardware. There was a time and a place where this was significant, not so much anymore. Same thing with overclocking, where you got a CPU and then you can overclock it, and then you got tons more performance out of it. For the most part, these manufacturers have gotten so good at squeezing all the performance out of their products that overclocking is not really worth it. Okay. So the example that I used to Intel-based gaming systems only see a 4% increase in FPS, and that is a ideal scenario for your DRAM. So 4% for your FPS, uh, not really worth it. Okay, DDR5 is focused on power efficiency. One of the things that's interesting about DDR5 that we're still going to discover, and as our engineers get better at producing them, is the fact that it can handle parallel processing on the RAM itself. So we'll see what we can do with that. That's going to be really, really helpful for server environment, less so for consumer markets, but generally speaking, a lot of the new standards that are coming out for hardware is not aimed at the consumer. It's definitely aimed at the server market. DDR5 is like that. PCIe Gen 5, we have a hard time saturating the PCIe Gen 3 lanes, let alone 5. PCIe Gen 6 is right around the corner. I'm pretty sure the standard for that is already set. So that'll be 2 to 3 more years before that comes to market. So it's not consumer oriented that these standards are for, at least these new ones. It's server markets. We'll see what new data requirements are like later on in the future, especially if we all move towards AI type software. We'll see. At that point, we'll need high performance systems, but we'll see. I still think ARM is going to take over, and then all this is going to be different because ARM is completely different architecture. Okay. Use cases, large capacity. Yeah, this just comes down to how many people are using it and what are you using it for. Again, a cache server, that's lots of RAM. Web server with a lot of concurrent clients. So if you're Amazon, yeah, right, a lot of people. VM server, so if you're running operating systems on that server, then you're going to need a lot of RAM. Okay. Note that if you have many DIMMs, so DRAM sticks, you should consider registered RAM. And the reason for this is because it's going to be more stable communicating between all those DRAM sticks between themselves, especially when it's engineered from the ground up to do that. Your CPU would have a hard time doing something like an 8-channel deal. And I don't even think there's an 8-channel consumer board. So there's a reason for it. RAM use case for ECC, we already talked about this a little bit. Mission critical, needs to be up 24/7. Military applications jump to mind again. ECC is one of those warm fuzzy blankets where you don't really need it, but a lot of places have it simply because it's there. The other factor is that a lot of places, in terms of businesses, they don't build their own servers, they buy them from integrators, and the integrator has to validate it for these particular workloads. So if they have to validate it for 5.9 uptime, they're going to use ECC. Okay, so that's going to do it for the RAM overview. Obviously, that was a fire hose of information. However, again, like I've been saying up to this point, these PowerPoints are used as references. I want you to know that these things exist. It is still an intro to technology course where we're not going to be doing any type of deep work into this. You just need to know that it exists and is there and that you can recall it when you need that information again. Okay. So with that said, that's all I got for this one, and I'll see you in the next one.